Hi, Calculus Honors students. This is actually a refresher lesson from the day one of optimization, the lesson that you learned before spring break. We had a special request from some of the students in our class for a little review on day one, which was area and perimeter and sum and product. So I'm going to skip example number 1. I'm going to show example number 2 and example number 3. So remember, for optimization, the first thing we want to start with is we want to create 2 different equations. And one of those equations we will probably have some numeric metric for a value. So the first thing they tell me is the product of 2 numbers is 192. The sum of the first plus 3 times the second is a minimum. Find the 2 positive numbers. All right, I don't know what to call those. I'm just going to call those x and y. And the first thing I know is that their product is 192, so x times y equals 192. My second equation says the sum of the first plus 3 times the second is a minimum. So the sum is what I'm making an equation for. And the sum would be the first, which I'm going to call x, plus 3 times the second, so plus 3y. And this is what I'm minimizing. So this is actually the equation I want to take a derivative of. I don't want to take a derivative of sum with 2 variables in here. So what I want to do is write the sum in terms of just one of these variables. Well, that's what I have this other equation for. So I'm going to take this other equation and I'm going to solve for a variable. Let's just say I solve for y. So y is equivalent to 192 over x. And now I am going to substitute this expression in here for y. So we have 192 over x. Now I have an equation with our sum written in terms of just one variable. I'm going to clean this up a little bit since I know in order to find a minimum, I want to find my derivative and set that equal to 0. So I don't want to have to use a quotient rule or a product rule. So I'm going to clean this up a little bit. So we have x plus 3 times 192 is 576. And I'm going to push that x up to the numerator. So 576x to the negative 1 power. And now I'm ready to take my derivative. So I'll just call that s prime equals derivative of x is 1. Let's use our power rule. So negative 1 times 576 is negative 576. X to the negative 1 minus 1 is negative 2 power. And now I'm going to set that equal to 0. And in order to solve this, I do find it helpful to rewrite this in its natural form. So that is 1 minus 576 over x squared. And I am going to slide one of these terms over to the other side. So I'm going to come over here. So I'm going to move my 1 over. And then I'm going to cross multiply. So I would have negative x squared equals negative 576. Multiply both sides by a negative 1. So we have x squared equals 576. When I take the square root of both sides, we get x equals, and the square root of 576 is 24. So we get plus or minus 24. And at this point, I would also then be graphing this on a number line to confirm which one of these values is actually a minimum. But I'm also noticing in the directions, it says find the 2 positive numbers. So I don't even care about the negative 24. In fact, I don't care about anything less than 0. So we have a little domain restriction. Anything less than 0 is off of our radar. So I'm going to substitute numbers between 0 and 24 and infinity. So if I substitute a 1 in, if I come back over here, 1 minus 576 over 1 would be a negative number. And if I substitute a number bigger than 24, I could do 25. I'm just going to do 1,000. If I substitute 1,000 in here, 1,000 squared is very large, which means 576 over that large number is very small, smaller than 1. So 1 minus that small number would be positive. So that does confirm, in fact, that we have something that is decreasing and then increasing. So we do, in fact, have a minimum. So my minimum happens at x equals 24. And they also want us to find both of those positive numbers. So I'm going to substitute this 24 in way over here. So we would have 192 divided by 24, which is 8. So our two numbers are going to be 24 and 8. Okay, we've got one more example that we're going to squeeze into this lesson, and this is example number 3. So we have a farmer that has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. Okay, so we've got this river here, and we have a building, a field, but we only have 3 sides to the field. So I'm going to call this width, and length. And the first thing they tell me is there is 2,400 feet of fencing. Fencing is like a perimeter. Now, traditionally, perimeter is 2W plus 2L, but in this case, we have 2 widths and only 1 length. And I'm going to substitute my 2,400 in here for perimeter. All right, so I have one equation representing that perimeter relationship. They're asking me to find the dimensions that create the largest enclosed area. So I'm going to start with just a generic area formula, which would be length times width, or in this case, width times length. Just because there isn't a 4th side to the enclosed figure doesn't mean that this still wouldn't have the same exact area that it would have even if it had a 4th side. So I have area written in terms of width and length, and my area formula is what I'm trying to find a maximum for. They want the largest enclosed area, which means I'm looking for a maximum. So I want to find the derivative, but I have too many variables here. So I am going to use my perimeter formula, and I'm going to solve for one of those variables. I'm going to choose to solve for L. That way I don't have to divide by 2. So I'm going to subtract 2W, and I am going to substitute length with 2,400 minus 2W over in this equation. So I have width times 2,400 minus 2W. And I want to take the derivative of this, but I don't want to use the product rule if I don't have to. So I'm going to distribute. So 2,400W minus 2W squared. And now let's differentiate this. So 2,400 minus 4W. We're going to set that equal to 0. Add 4W to the other side. W equals 600. And I'm going to come over here. I'm going to plot this on a number line. And I want to substitute numbers to the left and to the right. Now I know that my width, that was my input here, my width is a real life dimension. So it can't possibly be negative. So I do have a natural domain of only positive numbers. And so I'm going to substitute a 1 in, for example. Some number between 0 and 600, I'm going to use 1. So 2,400 minus 4 times 1 is definitely positive. Pick a more extreme number than 601. Let's go with 1,000. So 4 times 1,000 is 4,000. 2,400 minus 4,000 is negative. So I have an increasing function and then a decreasing function. So in fact, I do have a maximum here. So my maximum area happens when my width is 600 and they're asking me to find both of the dimensions. So I'm going to come over here. I'm going to substitute my 600 in. So that would be 2,400 minus 1,200, which is 1,200. So I have a length of 1,200. Now, just fair warning, some of your problems on your homework might ask you to turn around and identify that maximum area. If you needed to do that, we know area is width times length, so you would just multiply 600 times 1,200. Okay, good luck to you guys. Thanks so much for listening.